Solving using the quadratic formula. The quadratic formula is actually a very efficient way to solve quadratic equations, and you can solve every quadratic equation using the quadratic formula. So the only way to use the formula is first if the equation is quadratic. The equation is quadratic if you have an x squared term and if there's no x that has an exponent higher than a 2. So it has to have an x squared, but it can't have anything larger, like x cubed or x to the 4th, because then it would no longer be considered quadratic. So to solve, we first need to write it in the form ax squared plus bx plus c is equal to 0, which essentially means we need to write all the terms on one side so we have 0 on the other. So I'm going to start by subtracting 1 from both sides, and that's going to leave us with 6x squared minus 2x minus 1, I can't combine anything together, and then is equal to 0. So once I have 0 on one side, then I can identify the a, b, and c terms. So the a term is always the term in front of x squared, so I've got a is equal to 6. b is always the number in front of x, I guess I shouldn't say term. So in this case, the number in front of x is negative 2. So you get b is equal to negative 2. And then finally, c is your constant. So in this case, c is equal to negative 1. And you do want to keep track of the signs. So the 2 and 1 are negative, so I want to make sure I keep the negative. And now we're going to plug everything into that formula. So we get x is equal to, I'm going to start with my big fraction, negative b, so in this case b is negative 2, so I'm going to plug in negative 2, and then plus minus. So in black I'm trying to leave everything that's part of the actual formula, and that will always be there. The terms that I'm going to write in the different colors are going to refer to the a, b, and c that I plug in. So then I have the square root of b squared, which is negative 2 squared, minus 4 times, the 4 will always be there, times a, which for us is 6, times c, which for us is negative 1. So I guess I should have made this fraction line a little bit longer. And then all over 2 times a, which in this case is 6. So then what I'm going to start by doing is most of the multiplication. So in this case, a negative 2 is just going to convert it to a positive 2. Plus and minus the square root. Negative 2 squared is going to give us 4. And then I could actually multiply everything else underneath the radical sign as well, because we've got a negative 4 times a 6 times a negative 1. And so if I multiply all three of those together, that actually gives a positive 24. All over 2 times 6, which is 12. And then I'm just going to go ahead and rewrite this and now actually add the two numbers underneath the square root. So I get 2 plus or minus the square root of 28 over 12. So the last thing I want to do is simplify. If I am okay with getting just an approximate answer, I might just actually find the value of square root of 28, because it's not a perfect square, use that decimal and go from there. But if I do want to leave it as an exact answer but still simplify it, then I'm going to do something a little bit different. So at this point, once I've done all the multiplication and I've combined the numbers underneath the square root, I want to look at the number under the square root and see if I can reduce that. So square root of 28, like I said, is not a perfect square, but to reduce it I can break it down into factors and see if any of the factors are a perfect square. So 28 is actually 4 times 7. So 7 is not a perfect square, but 4 is. So if we took the square root of 4, we end up with 2. So to rewrite that, what I'd have, I'm going to leave the 2 plus minus. And now instead of square root of 28, basically the 4 I could actually pull out of the square root, and that results in a 2, because the square root of 4 is equal to 2. The 7 I wasn't able to take the square root of that, so that's left underneath the square root. So it's square root of 7 all over 12. So I've reduced the square root, and then the last thing would be to see if I could divide the numerator and the denominator by something to simplify it. So what I'm looking at is essentially this 2, and in this case it only divides with the denominator if it's outside the square root, so the 7 won't be able to reduce at all in terms of dividing. And I look at the 12. So I'm basically looking at all of these numbers and if they have something in common in terms of divisibility. And they're all divisible by 2, so I can divide everything in the numerator by 2 as long as I divide everything in the denominator by 2. So what that leaves me with is 1 plus minus the square root of 7 over 6. This would be a combined way to write the answer. Of course, what the plus minus means is you actually have two solutions, one where the plus is there and another solution where the minus is there. So if I write that out, let me write it in red here. Your solution set would actually include two solutions. One of them is 1 plus square root of 7 over 6, and the other one is 1 minus square root of 7 over 6. And those are your two answers.